Yes, this class will be discussing how to determine oxidation number. That's the determination of oxidation number of an element in a compound. Now, before we begin, don't forget to uh, like and subscribe to our channel. The oxidation number of an element can be determined with one of the rules here. But first of all, what is oxidation number? The oxidation number of an element in a compound is simply the charge the element carries or bears in a molecule of the compound. Now, to determine that, one should know that the oxidation number of oxygen is always -2 in most compounds except when it is a peroxide. In a peroxide, the oxidation number of oxygen is always -1, but the suboxide is -1/2. So most of the questions we'll be seeing are questions in which compounds in which oxygen carries a charge of -2. If it carries -1, they will let us know it's a peroxide. For instance, you can see in hydrogen peroxide or in sodium peroxide, what is the oxidation number of oxygen. Then secondly, when an element is uncombined, like a single element such as hydrogen standing alone as H2, or a single metal such as sodium standing alone as Na, then the charge of that element is 0 when it is uncombined. Then the oxidation number of hydrogen is +1 only when it combines with non-metals. But when it combines with a metal, then it carries the charge of -1, because when it combines with metals, it no longer forms hydrogen ion, but rather it forms hydride ion, as we discussed in our last lesson. So the number 4 here, the sum of the charges of the constituent ions of a molecule always equals the net charge of the molecule, meaning if you put all together, all the charges of the individual atoms or ions together, then it should give you what the entire group carries. If it carries no charge, then the charge is 0. We'll see it in the examples with time. Then the last, number 5, the oxidation number of metals are always positive. Metals do not carry negative charges. Only non-metals can carry charges that are either positive or negative. For metals, it is always positive. In most cases, when the metal is found in group 1, 2, and 3, then the charge will always equal the group of the metal. For instance, aluminum belongs to group 3, then the charge of aluminum is always +3. The charge of calcium is always +2, as calcium belongs to group 2. The charge of barium is always group 2. The charge of beryllium is always +2 because it belongs to group 2. Then the charge of sodium, potassium, lithium, rubidium, cesium, they are always +1 because they belong to group 1. Now let's see some examples how we can calculate these oxidation numbers. From this example, what is the oxidation number of nitrogen in CaNO2 bracket 2? Now the first thing, we can do this question, we can resolve these in 3 ways. In the first way, we can write out the compound NO2 bracket 2. Then we'll separate them into 2 cations. The 2 different ions, sorry. The first ion is the calcium ion, and the other half is the NO2. To know the charge of the calcium, you take these 2 for the NO2 to the top of the calcium, and because calcium is a metal, it becomes plus. Then the number of calcium here is 1. Number of calcium here, there's only 1 calcium here. So the number of calcium here, which is 1, you take it this way and take it to the top of the NO2. So since calcium is 1, it becomes 1 NO2. And don't forget, since calcium has a positive charge, it means the NO2 will carry a negative charge, because unlike charges attract, it takes a negative to stay with a positive. So we can now use this NO2 to solve for the charge of the nitrogen. From the law, we can write that the N, we don't know its charge, is X. Let's call it X. And the oxygen, the 2 oxygen, like it's said in the law. If you check number 1, from number 1, the oxidation number of oxygen, which is the charge of oxygen, is -2 in most compound. That is to say, the oxygen here can be taken as 2 minus. Then go to number 4. Look at number 4. Number 4 of the law said the sum of the charges of the constituent ions of a molecule equals the net charge of the molecule. That is to say, if we add the charge of the nitrogen and that of the oxygen together, it should give us this net charge here, which is -1. So we'll put the -1 here. So finally, we have one n here. 1n times x. 1 times x should give us x plus, because it said the sum of the charges. So 2 times -2 for the oxygen should give us -4. Everything will equals this negative sign, which is -1 here. So everything should give us -1. So from here, if we collect like terms, you will see that x equals -1. If this should cross to the other way, becomes +4, and that should give us +3. So the charge of nitrogen in this compound is simply +3. So we can call it calcium diazonitrate 3. Then for the next example, okay, in another way, let's quickly work in another way. In the second way, we can resolve this. We can just say Ca open bracket NO2 bracket 2. Simply assign charges directly. The charge of calcium, like we know, it's 2 plus. The charge of nitrogen, we don't know, we'll call it X. The charge of oxygen is -2. And the total charge here is 0. So if we add everything here, it should give us 0 because the compound is not carrying a charge, normal. So we can see calcium is 1. 1 times +2 for calcium becomes +2. Then remember, in mathematics, whatsoever is outside the bracket multiplies everything in the bracket. So 1 nitrogen times this 2 outside the bracket becomes this nitrogen times this 2 outside the bracket becomes 2 nitrogen times x will give us +2x. Then the 2 for the oxygen times the 2 outside the bracket will give us 4. The 4 oxygen atoms times the -2 for the oxygen will give us -8. Everything should give us the net charge of the compound, which is 0. So in this way, collect like terms, you can see 2x equals -8 should cross to the other side to become +8. Then +2 should cross to the other side to become -2. So everything will give me 2x equals +6. So if I divide by the coefficient of x, you see x will still give us +3. Now the next example, said what is the oxidation number of phosphorus in Be3PO3 bracket 2. The same way, we can use the first method, write the compound out, Be3, open your bracket, PO3 bracket 2. So spread it, can divide it, beryllium, here, this 2 moves to the top of beryllium to give it 2 plus. Then what is left is PO3, and this 3 for beryllium moves to the top of this to give 3 minus. So we can solve with this. So that is to say, if we say P, we don't know what it is, X, then O3, but the charge of the oxygen, like we said before, is 2 minus. Then everything, if I add the charges of the oxygen and phosphorus, it just give us that 3 minus. So therefore, we can simply say that 1 times the P of phosphorus should give us 1x. Then 3 times the -2 of the oxygen should give us -6. Everything should give -3. So collecting like terms, x is equal to -3 plus 6. That should give us plus 3. So this compound here, the oxidation number of phosphorus is also plus 3. So we can also do it in the other way. The other way we can solve directly. Write the compound Be3 PO3, put in a bracket 2. So the charge of this, because beryllium belongs to group 2, we call it 2. Phosphorus, we don't know, we call it X. Oxygen is 2 minus, so we can say this 3 for beryllium times the charge of beryllium. That's plus 2 times 3 for the beryllium, plus the 2 outside for phosphorus. That's 2 times the charge of phosphorus, which you don't know, which is X. Close your bracket, plus open bracket, the 3 for the 3 atoms of oxygen times the charge of oxygen, which is minus 2, minus 2. So everything should give us the net charge of the compound, which is 0. So from here, plus 2 times 3 should give us plus 6, plus this sign. 2 times x should give us 2x, plus 3 times minus 2 should give us minus 6. Everything should equal x. So from here, collecting like terms, it becomes 2x equal, if this crosses, minus 6 here. If this crosses, it gives if this should, sorry, the number of oxygen, there's a problem with oxygen here, sorry, we made a mistake here. 3 times 2 is 6. 6 times minus 3 times 2 is 6 oxygen. So 6 times minus 2 should give us minus 12, not minus 6, but minus 12. So we can now say collect like terms. 2x, if minus 12 should cross to the other side, it will become plus 12. So minus 6 should cross, plus 6 should cross, it will become minus 6. So this will give us 2x equal plus 6. Now making x subject to the formula, that's 2x equals plus 6. Divide both sides by the coefficient of x, which is 2. That will give us x equals plus 3. So the compound can be called beryllium triazophosphate 3 salt. What is the oxidation number of phosphorus in PCl5? Alright, so that's phosphorus pentachloride. So the first thing is to write out the compound Cl5, then split into the cation and the anion, that's positive and negative. The first element always carries the positive charge, that is P and Cl. Now the number of chlorine here, take it to the top of the phosphorus, so it gives us 5 plus, which is the charge of the phosphorus. Then the number of phosphorus here is 1, take it to the top of the chlorine, that gives us minus 1. So the charge of phosphorus in this compound is simply plus 5. Lastly, what is the oxidation number of sulfur in CaS, that's calcium phosphide? Then we can say, write it out, CaS. What are we supposed to do? Split Ca, then S. Now in this case, if you take the number of calcium here, you will get it as minus 1, and if you take the number here, you will get it as plus 1. Alright, so if we have this as plus 1 minus 1, there it will give us Ca plus and S minus, but there's a problem. I told you, or rather the law said the oxidation number of metals in most cases agree with their groups in the periodic table, especially when the metal is of group 1, 2, or 3. So to make the charge of calcium agree with its group, you multiply it with a number, and whatsoever you do to calcium, you should do it to sulfur. So if I put a bracket and I add 2 outside, 2 times 1 will give me Ce 2 plus 2 times minus 1 should give me x2 minus. So this agrees with the charge of the group of calcium, and this agrees, the sum agrees with the charge we see on this compound. The charge on the compound there is definitely 0. Plus 2 minus 2 gives us 0. So with this we have concluded, or we have gotten to the end of this short topic, this short lesson. So don't forget to subscribe to our channels to get more information. Thank you.